really quick, make this a 3-minute video using the chain rule to find the derivative of the function sine ax. And sine is just a coefficient. You could put any number there, and this is going to work the same way. Whether it's a, 0, 1, 2, 3, f, q, it doesn't matter. It's going to work the same way. Don't let the a throw you off. So the first thing we're going to do is look at this, and we're going to break it down, and we're going to say there's two functions. One of them is nested within the other. We have an f of x, and we have a g of x. Okay, so the g of x is ax, like 2x or whatever you want to call it, is the inner function, and then the f of x is the outer function. Now when you're trying to make sense of if you look up chain rule and you see this weird long thing that talks about f of x or equals the derivative of f of x equals look, I'm not gonna get into the details of it. You'll see what I'm talking about when you try to look into chain rule. But this is explaining what that f of x and g of x is, the outer function and the inner function. That's all it is. It's just notation, just saying this is this and that is that. To actually apply it here, what does that look like? Well, the derivative of sine is cosine, and that you'll have to look that up if you didn't know that. It's just one of those funky rules that's predefined. There is a way to prove it. And you keep the whole function when you're doing this. So cosine a of x, or I'm sorry, cosine ax is going to be, that whole thing is the derivative of the outer function, and then we combine that with the derivative of the inner function with multiplication. So cosine ax times, and over here we can just do the derivative and just remember, we're looking at a like it's a coefficient. So just picture it like you have the 1 up here, and you swing the 1 down. 1 times a is a, and then 1 minus 1 is 0, so you're going to be left with just a, right? You're just treating it like a coefficient times a, and sure enough, just as quick as that, f prime is this, and we can throw the a on front just to kind of simplify it. A cosine ax, and I'll throw this in Desmos. I already have the original function in Desmos, sine ax right here, and I'll throw this one in Desmos just so we can kind of see what it looks like. Is it really the derivative? And if you look right here, the green one is the derivative, and when it hits 0, the output of the derivative is describing the slope of the antiderivative, the original function, the integral, right? So pi halves, it's at 0, which means the slope should be at a local min, a local max, some kind of critical changing point, right? And in this case we have a local max right at pi halves. We have pi halves 1, and then the slope starts to decrease after that. And so we can see right here on Desmos, it's pretty quick and clear. Everything does kind of check out, and that's how you use the chain rule.